Hi, everybody, and thank you for joining me here for this recorded presentation on the O'Dive Doppler sensor device. Now, I'm recording this because some of you were interested in hearing more about how this Doppler sensor can help you personalize your decompression planning, but you weren't able to join the live presentations that we did in April 2021. So what is this presentation all about? I'm going to start sharing my screen so that you can see a little bit more. So it's all about taking your decompression planning personally. I'm going to talk to you about the ODive Doppler sensor device by Azoth Systems and how I have used it for my personal diving, both for fun dives, but also for dives with clients at Dark Horizon Diving in Bali here over the past 3 to 4 months. For those of you that I haven't spoken to personally, that haven't met me before, my name is Yvonne. I am based in Bali for 7 years now. I've been here for 7 years now. I started my own small tech diving shop, Dark Horizon Diving, nearly 2 years ago, just before the pandemic, with slightly awkward timing, but I'm still here and still diving. I'm a technical diving instructor trainer, and most of my diving is decompression diving. However, I still teach recreational level diving, no-stop diving as well, mostly side mount, solo diving, that kind of courses. And it's been interesting to use the device over a different range of dives. So what do I want to cover in this presentation? Let me see that it moves. There we are. There's 3 parts to it. Part 1, I want to tell you a little bit more about what the ODive is, what research it is based on, how calculations are made by the device. Then I will come off the shared screen and show you how you take measurements, how it actually works. And in the third part of this presentation, I'm going to share some of the initial findings that I have had for myself and for my dive buddies, for guests that have dived with us here over the past 3-4 months. So let's jump ahead. What is the ODive? It is a handheld Doppler sensor for day-to-day use. So it is not a scientific measuring device in that sense. If you want to compare it to something, think about the blood pressure monitors that you can use at home to check your own health, to check how your body is doing. That's the idea behind it. It is to give divers a day-to-day way of measuring how their body has coped with their dive and developing a way of making dives safer. So it allows you to measure post-dive bubbles in your bloodstream. The data is collected in an app. You're uploading your dive profile to that app as well. And these 2 things, the measurement and the dive profile that you've uploaded, are then processed. How many measurements are you taking? The idea is to take 2 sets of measurements. When I'm talking about a set, I mean one on your left side, just under your collarbone, on your subclavian vein, and one on your right. That would be 1 set. And then a second set somewhat later on. If your dive has been on air or nitrox, you want to be measuring 30 minutes after the dive and 60 minutes after the dive to catch that peak time of off-gassing. If your dive has been on a high percentage of helium in your gas, then you want to measure somewhat earlier because off-gassing happens faster. Bubble measurements are combined with the dive profile. This information is then processed by a server in France owned by Azoth Systems. And within minutes, you have a result back. That result is called a quality index, a rating of your dive. I will talk a little bit more about that in a few minutes. The research behind it is something that I want to introduce you before I talk more about the results. The manufacturer Azoth Systems has been, for more than 10 years, creating customized decompression profiles for mostly commercial dives. So the dives that I do here, the dives that many technical divers will do, are almost on the smaller dive end compared to what Azoth Systems has been dealing with. They've covered depths to more than 500 meters, and they've been working with some of the biggest names in commercial diving, Comex, CalDive International, companies like Total. There's a research and development team of 7 people, and there is a database of well over 1 million dives on which the ODive's ratings and its simulations are based. When I first became trained to use the device in January 2021, about 4 or 5 months ago now, it was 1.2 million dives. That number will have grown up since then, because every single dive that divers like myself and others are recording and sharing are being added to that database. The ODive is Azoth Systems' first consumer product. So it is the first time that they are reaching out to a market of divers who dive for recreational purposes rather than commercial divers. And how does it work? What do you actually get to see? What you see here on the left is a little bit of a dashboard of dive ratings. If you look at the graphic, you see over on the left, there's a scale that follows a traffic light system. So if your rating lies between 0 and 50, it's orange here, you're in the red, that means you could do better. Your dive could be safer. You've got probably quite a few possibilities to make that dive potentially safer. If you are between 50 and 75, a rating of between 50 and 75, you're in the yellow. And you see that here with the first 2 dives that I included in here. Now, you're doing better, but there's probably still room for improvement. Not as much room as there was if you had had a lower rating, but you can still eke out a degree of safety, add a degree of safety to your dive. Once you hit ratings of 76, the quality index of 76 or above, it means that your dive profile is pretty much optimized for bubble formation, for how your body is coping with it. You might still be able to eke out another sort of 5%, 10% to make it still safer. So how's the quality index determined? Bubbles measured by the device after your dive are one component. The other component is the severity of the dive profile. Obviously, there are things like depth and time spent at the depth, but there's also the ratio between on-gassing and off-gassing that plays into this. From those 2 components, the quality index of the dive is derived. So far, so good. Now, one last thing for now. I'd like to let you listen to examples of raw signals of the sound recorded by the ODive. The first one here is the signal without microbubbles detected. So this is what your bloodstream would sound like to an ultrasound device if you haven't been diving. You can hear the heartbeat, but you cannot hear much else. Now, let's listen and compare this to a signal with a large amount of microbubbles. This is something recorded between 30 and 60 minutes after a dive. You can hear the bubbles almost as if it's a form of turbulence picked up by the device there. So it's a distinct difference, really. Now, time for a demonstration. So this is when I stop sharing my screen and instead show you what the device actually looks like. So it comes, I better turn this the right way around, in a small Pelican case style box. sensor itself is a small handheld device, and you can see here the shiny part. This is where the actual recording happens. Another thing you can see is that it is shaped to fit your collarbone, to sort of sit on your collarbone. This is to help you find the correct position on your subclavian vein. Also included with the device is a handy bottle of ultrasound gel that the device needs in order to record signals, as well as a charger, a mirror that would help you position the device correctly. Now, it is only as good as the app that goes with it. So let me get my phone up and running. And then this is a quick look at the camera movements. So let's see, there we go. So you've got 4 fields there. You've got a new measurement at the top there. You've got accounts underneath. If I touch accounts, you see there is a number of different names. That is because I have used it with my dive buddies, my students, my guests for the last few months. This is the Dive Center version, so it allows me to pretty much set up as many accounts as I like. We then have at the top a new measurement. Then we have my dives. This is where I would be uploading the dives. And then below we have my results. Now, you see here, it's asking me to pair the app with a sensor. I'm not going to do this because I am going to lose the connection that I need for recording this if I were to do that. So I'm going to put the phone to the side for the moment and come back to the sensor itself. When you're starting up the device, you would simply touch the top and via Wi-Fi generated by the device, just like your GoPro would, you connect to your phone. So you don't need a Wi-Fi signal. You simply need the Wi-Fi capability of your phone to be activated. You can be out of range for the recording of the measurements. You do need to have some sort of signal, Wi-Fi, 3G, 4G, in order to send your data that you gathered over to the manufacturer. Now, I would want to start on my left side, and I'm just going to go and find my collarbone here. Remember, the device is shaped so that it's easy for it to sit on the collarbone. I'm seating it, and then I would position it towards my shoulder. Now, I don't really have to guess because the app is giving me a screen where it's telling me how good my signal is. So it's pretty much saying I can hear something or I cannot. Things that are important is that I hold it with the opposite hand so that the arm on the side that I'm measuring is relaxed. It's better to sit, to be relaxed, than it is to stand up. And then you would simply take a 20-second measurement. Again, the app is clever. It does then, after the measurement, tell you whether you've taken a good measurement or whether that measurement doesn't have a great signal, whether it can't be exploited by the device, anything like that. So you're pretty much getting instant feedback. Once you are happy with what's happened on your left side, once the app is happy with what happened on your left side, you simply then move on and repeat the process on your right. That is one set of measurements. About 30 minutes later, you take a second set. If, for whatever reason, dive logistics, anything like that, you cannot take that second set of measurements, that isn't the end of your analysis. There is about a 90% accuracy based on one set of measurements alone. It is just that bit more accurate if there's a second set of measurement that the initial measurement can be compared to. So ideally, 2 sets of measurements. If that's not possible for whatever reason, it's perfectly acceptable to send 1 set of measurements combined with your dive profile off to the manufacturer. How do you upload your dive profile? That depends a little bit on the dive computer you're using. If it is something like a Shearwater Perdix, it will automatically connect via Bluetooth to your phone and upload the data. That also works for some Mars computers. If it is a different computer, you may have to use an app like Subsurface, a dive log app, upload your dive to that, and then transfer it over. But that can be done really at any time. Obviously, if you want your results back quickly after your dive, then what you want to do is take your measurements, upload your dive, send the information off so that you can immediately apply the results to your next dive. If you are not going to dive again for a couple of days, you've got plenty of time to get all of that organized and recorded and done. So much about how the device works. I'm going to go back to share my screen. Make you a little bit more jealous with another look at the mola mola, in order to now actually share some findings with you. Now, the exclamation marks are there for a reason. They are preliminary findings. We've only been using the device here for a few months, and they are personal. Most of the data you're going to look at are my personal dives. Some of them are the people that I have dived with, so that there is a comparison. What are those findings? To sum them up, I have adjusted my gradient factors to be no longer a one-size-fits-all. That was an approach that I used for a number of years, and that worked not badly, but I found that by tweaking them, I can actually make them fit the dive better. I have learned that the ratio between bottom time and deco time matters as well as the gradient factors, so that there's a connection between the two. Another thing I've learned is that there can be quite a bit of variation between two individuals completing the same dive profile. I will show you this on the example of the recreational, of no-stop dives. And the other thing, and that's probably been the biggest surprise, never underestimate long, shallow dives. By shallow, I mean 30, 35 meters rebreather dives. So let's take a look at it in a bit more detail. Entry-level tech dives. What I mean by that are dives that you would complete if you've just finished a qualification, like your TDI Advanced Nitrox Deco procedures, like your PADI Tech 45, for example. Let's take a look at the graphic first. On the left, we've got a traffic light system again, that you saw a little bit earlier. And then we've got our results column. We've got 76 out of 100 for the quality rating of this dive, which is not bad, but there is room for improvement. There are 24 points missing there, and we have got a note that our gradient factor low could be changed, that it's inappropriate. Now, for these types of dives, at Dark Horizon and also at my previous position, I would generally use a gradient factor of 40-70. I had found that worked okay. And it seemed to be generally accepted for dives done around here by myself, by other instructors, by other divers, as being a good, sensible gradient factor. Now, we complete these dives here, generally still on air as a bottom gas and nitrox 50 for deco. Now, 45 meters with air as a bottom gas is already pushing, well, it's actually exceeding recommended gas density limits. It is still well within training agency standards, but if you're starting to look at gas density limits, this is a depth where you really ought to consider Helitrox or Trimix. Why do we still do them on air? Because we generally have very, very favorable conditions. What I mean by that is warm water between 27 and 30 degrees. In Fahrenheit, that's high 80s. We have blue water, good visibility, not much current, or at least if it is, then it's a reef current running along and pretty much just following us along on our dive. And we're on sloping reefs, meaning that even if we picked 45 as a maximum depth, we can shallow up as soon as we find that our workload increases. So really, as far as technical diving goes, we have very, very, very favorable conditions most of the time. These dives generally run around 60 minutes, maybe 70, with 20 to 25 minutes of bottom time, followed by 30 to 35 of ascend and deco stops. What we found with the ODive is that gradient factor low of 40 is unnecessarily conservative. Having changed it to 50-70, we found that we've got similar or better quality index results. Now, I've talked a little bit already about the difference between air as a bottom gas and Trimix as a bottom gas. And that's what you're looking at here. Looking at the graphic on the left, we've now got a bit more of an interesting result. Still a 45-meter dive, but you see this time the diver only scored a quality index of 60. The diver lost 20 points to bubbles, that's the lower 20 in the darker blue, and 20 points to the degree of severity assigned to this particular dive profile. You see there's a relatively gradual descent to the maximum depth, then quite some time at the maximum depth, then an ascent to the first stop, and then the deco stops there. Now, this dive was done using air as a bottom gas. On the right, you see the difference between the quality index rating that you scored, that's the 60, and then over on the right side of that column, you see the result of the simulation made by the device. How do you make the simulations? You simply play with the sliders and the other options underneath that result. So you see there are options for an additional decompression stop, different decompression gases, bottom gases, gradient factors, etc. In this case, all I changed was I changed the bottom gas from air, you see that on the left side, it says Trimix 210, so that is air, to, on the right side, bottom gas, Trimix 2135, standard gas. Now, the app predicts that doing the same dive on a Trimix 2135 would improve my quality rating from 60 to 85. According to the app's prediction, the bubble load generated would halve, and the severity of the dive would reduce from 20 to 5. So you see, we would gain quite a level of safety. We would increase our safety by 5.7, really, if we changed our bottom gas. Now, we haven't had the opportunity yet to prove this. This is a simulation. The idea is that you do the dive, you look at your result. If you think your result can be improved, you run a simulation to find out what has the biggest effect, and then you go and dive again and prove that. On open circuit, haven't had the chance to prove that yet, but we do have some interesting data that actually confirms this for CCR Dive, so just bear with me for that. I did also add things like additional deco stops, but in this particular case for this dive, changing the gas made the biggest difference, had the biggest impact on improving the safety rating. So I promised you CCR dives, and here they are. Mod 2 level, so that means depth 60 meters, that is about 190 feet, I think, more than 180. So depth of 60 meters, runtime of about 2 hours using 2 different bailout gases, 1 deep bailout, 1 for deco. This particular dive, and this is a profile that myself and my dive buddy have done quite a lot of in the last few months, had a 60-meter maximum depth and a maximum of 75 minutes of time to surface based on team bailout. So you see there's a gradual descent to the maximum depth, and then an ascent and quite some time spent on various deco stops. What we found for these dives is that the gradient factor of 40-70 tended to deliver good results overall and better results than 50-70 based on the amount of dives we've been able to test it on over the last few months. So still bear in mind, this isn't from these personal findings that I'm sharing, it's not a huge amount of data yet. So in this case, you see the diver scored 80 out of 100, with only 20 points in this case lost. Additional deco time, that's the slider you see at the top there, additional deco time of 10 minutes would have increased the safety rating of this dive to 86. So that would have been something to consider. Where we are here, hypothermia is not usually a big consideration. So adding 10 minutes is not a great hardship in most cases. We're also on sloping reefs that literally stretch up to the surface. So we can actually follow the reef up. We're not hanging in the blue. We're not drifting out of control. Adding 10 minutes here generally is perfectly possible, perfectly plausible, and worth considering because it does increase our safety. Slide number 2, dealing with CCR Mod 2 level dives, is a comparison of different gradient factors. When I trained as a technical diving instructor, I initially was still advised to use BPM as an algorithm. I've since changed to Bullman ZHL16C with gradient factors. And when I made that change, I was advised by my trainers that a gradient factor high of 85 would generally be considered conservative enough. So what you see here is a comparison of a gradient factor high of 70 and a gradient factor high of 85. Of course, you can tell me, you can see this immediately, those dive profiles are not the same. So let me explain them a little bit more. On the left, the dive that scored a quality rating of 78 with 10 points lost to bubbles and 12 points lost to severity. That dive was a multi-level bottom time with about 25 minutes spent at 30-35 meters, followed by another 25 minutes at 60 meters, roughly. The dive on the right, the one that had a rating of 84 out of 100, that dive had a maximum depth, you see that little dip there, to 55 meters. The rest of the bottom time was spent around 45, a little bit of time at 50. So overall, that dive did not have the same depth. So what we're seeing, though, is that whilst in this case, these are both my results, my bubble formation, the bubble formation in my body has been 10, has been very similar. By using gradient factor high of 85 for that dive on the right, I increased the severity, I increased the risk attached to this dive profile quite significantly. What would have been the difference in underwater time? Give or take about 15, 17 minutes, something like that, which again, taking into account where I'm diving and the relatively warm water, relatively good conditions by comparison, I could have done and would be a good idea to do. Now, on the other hand, if there is something untoward happening, if, for example, you can feel that there's a big swell building and there's maybe danger of your boat struggling to cope with that swell, then maybe you want to make the decision to run a less conservative gradient factor. But what you're seeing here is actual feedback that you are increasing your risk and that you then need to make a decision whether you're okay with that level of risk. And now, the reason I was interested in testing that is that I figured out for myself that gradient factor high 85 is too high for me if I do repetitive dives, whether that is on the same day or whether that is a week of big dives. And especially, this is even compounded by me having to perhaps carry tanks after the dive. Why carry tanks? Because I do work in diving. So most of us, if we're diving professionals, we may choose not to carry too many tanks at the same time. We may choose to walk slowly to keep the exertion to a minimum. But most of us, most of the time at the end of a dive, do have to work or take gas blending at the end of the day. Most of the time, gas blending means moving tanks around. Even if you're just shuttling around the ones that you need to fill, it's a degree of exercise, it's a degree of exertion. So I found that 85 simply left me feeling tired, fatigued, which is what prompted me to then change the gradient factor high I was using, and I've brought it down to 70, which seems to work fine most of the time. However, there are times when even running on gradient factor 40-70 has not been the ideal solution. And this is one of these times. Photo dives, I call them the big surprise because they really were a bit of a wake-up call. So let's take a quick look over on the right. You've got the dashboard there again. And if you remember the dashboard I showed you before, there were some yellow columns, there were some green columns. Now, here we have quite a low rating of 30 out of 100, and then a couple of ratings of 60. These dive profiles were what I would class as, for this area, a classic CCR macro photography dive. 35 meters, give or take maximum depth, 2-hour runtime. If you're basing your dive on a gradient factor of 40-70, that will allow for approximately 40 minutes of approximately 80 minutes of bottom time, followed by approximately 40 minutes of deco, give or take. The big difference between the two detailed dives that you're seeing in the middle of the slide is the diluent. So dive 1 completed on air diluent, short little spike to 38 meters, but generally most of the bottom time completed between 30 and 35 meters, and a rating of 30. 20 points lost to bubble formation, so that's already quite significant. And 50 points lost to severity of that dive, how hard that dive is considered to be on your body. Next dive, similar profile, 33 meters maximum depth, but pretty much the whole bottom time spent more or less around that depth. But diluent changed to a trimix of 1835, something that you would be able to dive if you are qualified as a rebreather helitrox diver. So if you simply add that maximum percentage of helium of 35% to your Mod 1, your first level CCR course. Now, you could say 63 is still not an excellent result. True. However, changing really mostly one thing, changing the diluent from air to a trimix has pretty much doubled the rating of this dive. There was no significant bubble formation picked up by the sensor. 37 points were lost to the overall severity of the dive, and I discussed these results with the manufacturer of the ODive, with Azoth, and they confirmed that pretty much that severity is based on the ratio of bottom time, around 80 minutes, to deco time, around 40 minutes. So you see, we predicted previously that when we looked at entry-level technical dives, that using Trimix as a bottom gas compared to air as a bottom gas might increase the safety of our dive significantly. And this is pretty much what we saw, and I'm basing this on the findings for 2 of us over a week. This is what we saw doing similar dive profiles, not changing anything else, not adding additional decompression or anything like that, but really just going from air diluent to trimix diluent between the dive profiles. Our ratings improved. The other thing we found is that if we do want to improve the ratings even more, so if we do want to improve on that number of 63 there, the next thing then to do would be to look at the profile. Now, we are following our computers, we are completing the whole dive, we are following gradient factor 40-70, which is relatively conservative, but there's obviously room for improvement there. So, what can we improve? We could, for example, based on a 120-minute dive, simply divide our dive into thirds and spend the first third at about 35 meters, the next third at about 25, and then complete our deco. I have done that on one dive, and the result was better. It was in the 80s. Now, one dive is not really a lot of data to share, but that seems to be a potential option. So what has the ODive done? In case of these dives, it's really been a wake-up call. That is something, these results are not something I expected. And whilst you could say, well, why did you not expect that? Simply didn't. But this is feedback based on an actual diver's body rather than theory and interpretation of algorithms, which is very good already, but it doesn't take you as an individual into account. So, promised you to look at differences between divers, and this was done based on recreational dives. So we have the first dive at the top there and the second dive at the bottom, and we have diver 1 on the left, diver 2 on the right. One dive to 24 meters, one dive to 32 meters. These dives, you see on most of them, it still gives you this inappropriate gradient factor low warning. These were done before we changed from 40 to 50, so don't be too distracted by that. What I want to draw your attention to is that on these dives, diver 2 scored pretty much the same rating for both dives, 96 and 95 respectively, with a few points lost to a bubble formation. Diver 1, however, started out coming from the first dive with a lower score already, but then that score also decreased by quite a lot more for the second dive. So very similar dive profiles. What were the dives like? This was taken on a side mount workshop. That means there was a level of work as in equipment adjustments, taking tanks off, putting them back on involved, but there was no hard swim against the current, for example. So there was some level of work, but nothing really outstanding, nothing that would make me say, well, okay, on dive 2, diver 2 worked a whole lot more. So what could diver 1 do to improve that score of dive 2? One very simple solution would be to extend their safety stop. Be an easy consideration, not to only do 3 minutes in 5 meters, but maybe 10. If that's possible with gas supply, with anything else, then that is a consideration. And the thing to do then would be for that diver to have a go at that and see what the results are when they're coming back. So interesting to see that on very similar dives with very similar workloads, 2 divers can really deliver very, very different results. So that means if you're diving with a buddy, it's worth checking both of you and potentially changing your plans according to what works for the team. Summing up all of the stuff that I've presented over the last, give or take half an hour, I think, after 3 months of using this device, there will still be more adjustments needed. So this isn't the final conclusion at all. And remember, this is only based on a very small sample, very personal dives in a very specific area. I would expect actually that in 6 months, I would have more to add to that, either to perhaps confirm what my preliminary findings are, or to maybe tweak them. So I believe that personal decompression information will take some of the guesswork out of decompression planning, especially if you're new to this, especially if you're learning, if you're relying on your instructor to at least give you a starting point. With this, your starting point can already be based on you. It can already be a lot more personal to you than it has been so far. The ODive does depend on users taking measurements with a degree of diligence. It isn't a scientific instrument, but it's a user-level tool. Of course, if you are on a liveaboard boat as part of a scientific study, and you would have a hyperbaric physician taking measurements with a more complex device, those measurements would be more precise. There's really no doubt about that. However, how many of us can be a part of these studies? How many of us are realistically able to integrate that with our diving? And this is where this device comes in. It is there for you to integrate with your day-to-day diving and help you draw conclusions from your dives over a number of dives and make that diving safer. I believe it is incredibly useful for technical diving instructors, technical divers, but also for people who dive frequently on liveaboards. In Asia here, it is not uncommon that a liveaboard will offer 4, sometimes even 5 dives per day. And to be able to see how these repetitive dives, the impact on your body, to me, is hugely valuable. Those returning to diving after decompression sickness or maybe after severe injury, it would give them a chance to come back with data, of course, still step by step, but actually with direct feedback as to what's going on in their body. And anyone just wanting to know more about what's happening in their body with diving. Saying all of that, nothing replaces conservative dive planning and good judgment. Just like your dive computer, this device and the app will not do your dive for you. You still do need to do that. You're still responsible for your dive. Now, if you've been wondering about this, how much does it cost? The device comes in different levels of software. So the device itself is the same that you would receive. What then changes the cost, changes the amount you pay, is the capability of the app behind it. Can it deal with Trimix? Can it deal with dives beyond certain depths? Can it deal with CCR diving, etc., etc.? The basic device starts, recreational diving level starts from 535 euros, give or take, excluding that. And then it steps up towards 1,000 euros for the dive center and instructor version, all dependent on the software package that comes with it. Options include recreational version, CCR capability, Trimix, Heliox options, and the dive center instructor version, which includes training for instructors. That is valuable because placing the device isn't exactly difficult, but it does take a little bit of care and it does take a little bit of trial and error. If you want to know more, if you're perhaps considering ordering one, Dark Horizon Diving, myself, are a dealer for this. So you've got contact details there. Feel free to get in touch. And simply if you want more information, obviously, as well. If this was a live presentation where I would open the floor to questions, because it is simply a recording, I will go back to not sharing my screen anymore, but you do have contact details there. So if you'd like to screenshot them, get in touch, or if you'd like to send us a message on YouTube where this will be posted, that's absolutely fine. So I hope this has been interesting. I hope you found that the information presented was useful, that it was maybe applicable to some of your dives. Has the device revolutionized my diving? No, but it is evolutionizing how I am approaching different types of dives. And I am using it for students, for guests, to simply get direct feedback as to how our dive profiles are working for us. Thank you very much for your attention once again. Do feel free to get in touch to find out more. If you have any questions, happy to share more. What I'm thinking about doing is potentially doing an update on this presentation, probably in about 6 months' time, when we have a bit more data to share. Okay, for now, thank you very much.